All right, give me a second here while I put together a few more things. Okay. So once my camera stops wiggling, very similar setup to what we had last time, except this time it's gonna work. A thing in there? What are you talking about? Are you talking about the outline, Roy? Oh, okay. Yeah, I don't know. I was trying the outline because I feel like it's, I don't know. I thought it looked cool for the like IRL scene stuff. And this is a new camera. I don't know if you can tell because it's supposed to be better, but I think I have to play with the settings a bit more. So, I don't know. Does it look any better? Be honest with me. Yeah? Okay, cool. So last time didn't work at all. But I figured it out. I was gonna try trying to figure it out with the robot operating system. I kind of backed, and you might have heard me mention on a previous stream that that's what I was gonna try. Oh my gosh, my audio is peaking, it looks like. Maybe if I just talk like this. So I was gonna try the robot operating system, and that's still ultimately what I want to move towards. But I backtracked and went back to Adafruit's Python module stuff because it works, and what I needed to fix was not as horrible as I thought it might be. So anyway, we're just starting over. We're going to do the whole thing that I did the previous stream with this stuff again, so everything has a nice flow to it. You think the audio is fine? Okay, good. I see my audio level, and it's like a little bit too much in the red for my liking, but anyway, you let me know if it gets annoying or doesn't sound good, and I'll fix it. But for now, I'll assume that it sounds good and go with that. So, starting over from square one, we have a Raspberry Pi. Raspberry Pi 4, actually. I had the Raspberry Pi 5 last stream.
Glad to hear the audio is crystal clear for both of you.
Okay, Star.
Enjoy the cosmic vibes and seamless communication. Let the journey through space and sound continue. Musical note.
Thank you for that, Star. We had a Raspberry Pi 5 before, but I came to learn that the Raspberry Pi 5 is not everyone else is caught up to the Raspberry Pi 5, and everything that's more like Python stuff, robot operating system stuff, they're all Linux distributions that work on the Raspberry Pi and ROS, so on and so forth. Compatibility-wise, the Raspberry Pi 4 works better. So that's what I'm using now. Yeah, I like how Star added the musical note at the end. Okay, so that was the number one thing I learned. Number two, we won't see that here in this scene. Right now, I'll just be assembling the stuff. But the number 2 thing I learned was that last stream that I attempted this on, we had some issues with Python not wanting to install modules we needed because it would interfere with the environment that was on the operating system itself, and it's preferred that we used a virtual environment so that we don't mess up the environment in the operating system itself and just keep everything nice and clean. So I figured that out with Docker containers, which we'll see later. We'll begin with just assembling everything. So this part's not too hard. We have the Raspberry Pi 4, like I said, and then we have this, I believe it's PCA9685 Adafruit makes these and sells them. There's also similar components on Amazon, which is where I got them from. Probably bootleg, but it works. So the important part is that you're using a PCA9685 if you're doing the same thing that I'm doing here with Servos. Oh, you're all good, Senti. Just thanks for being here. I know I'm streaming way late, but I had figured everything out, and everything's fresh in my mind, so I just wanted to do it. So, okay. Now, let's start putting things together. When you get your Raspberry Pi, it might come with, if you're doing anything similar to this, if you get a Raspberry Pi 5, or 4, it might come with a pinout that tells you what the different pins mean, and that's important when you're trying to connect this PCA9685 to the Raspberry Pi. So we'll need, I don't think it's going to show up on the camera too well, but we're going to use first pin. We're going to use 4 pins on the left side. So the 3.3 volts, the SDA pin, the SCL pin, and the ground pin. We're going to skip that 4th pin. Okay, so I'll start doing that. The 3.3 volts, and in case it wasn't clear, this pinout maps directly to these pins here. So we're going to connect the 3.3 volts with a red wire, because power, and that makes sense, right? And then this PCA9685 also has its pins labeled just on the inside here, next to the pins. I'm not going to even try to show it on the camera because I know it's probably not going to show up. But you're going to just have to believe me that next to these pins are labels for ground, SCL, SDA, and VCC. So we're going to connect the 3.3 volt pin to the VCC pin on the PCA9685, like so. And then the next pin is the SDA pin. I'm just using yellow. Colors don't really matter, but usually power is red and ground is black. And I don't know, SDA and SCL might have colors too, but I'm pretty new to this stuff myself, so. Why are you talking about pi? What do you mean? Sorry, what? Oh! So, yeah, you know, that's a great question. I don't know why it's called the Raspberry Pi. I don't know how it's got its name, but when I'm talking about the Raspberry Pi, I'm talking about this. And you might see on the board here. If I can figure out where my finger is. There's a raspberry on the board right there. So I don't know. I don't know where. Maybe you can ask Star where does Raspberry Pi get its name from. But that's what I'm talking about when I say Pi. All right, so SDA pin is next. That's the second pin on the left side. And that is gonna go to the SDA pin on the PCA9685 right there.
Raspberry Pi is named after fruit, keeping in line with previous computer naming conventions like apple and acorn. It's a playful nod to simplicity, affordability, and the vibrant potential of this tiny yet powerful computer. Enjoy the cosmic baking, Pi.
Well, hopefully that's an accurate... I could see that, though, I guess, maybe. That might be worth cross-checking, because Star likes to mix things up sometimes. Okay, so next we have the SCL pin, which is the third pin on the left. To SCL on the PCA9685. And then finally, ground. We're going to skip the fourth pin on the Raspberry Pi and go to the fifth pin because that's what pinout says is ground. And finally make that connection to ground over on the PCA9685 right here. So let me see if I can get this better on camera. Actually, I'll show it. Maybe if I put my finger in the back here. Well, I don't know if you can really tell, but that fourth pin we skipped, and we're using the first five pins, but skipping the fourth pin. And then PCA9685 looks similar to this. 2 pins are not connected. The rest are. The pins that we're not using are the 0E pin and the V plus pin. So the 0E, I'll be honest, I have no idea what that is. I haven't had to use it yet, so I didn't learn about it. V plus is if you want to chain, you can change, sorry, tongue twister. You can chain these PCA9685s so that you can connect even more servos. So if you want to chain them, then you can continue the power to the next PCA9685 with that V plus pin. Okay, so Raspberry Pi and the PCA9685 is connected, but this PCA9685 needs its own power. Now the Raspberry Pi will get its power from here. With the 15-watt power adapter connector. Here we're using, oh man, I forget off the top of my head. But basically, it supplies 5 volts, I believe. I'll come back to this, what this is exactly, or maybe it tells me. Yeah, it should tell me, right? Yeah, so it outputs 5 volts and up to 10 amps. So there you go. And the reason why that is because the servos have an operating voltage, right? And then you need enough current to power multiple servos. So these servos I'm using are kind of hefty. In the torque they provide. They're not the most hefty, but they're also not the lowest torque you can get. So it just depends on what you're working with. So hold on, let me check chat. Oh yeah, Roy just commenting on not trusting Star. Good, good note there. Okay, so now what do I want to do? I want to connect the power. So we have this little adapter here because, of course, this connector isn't going to connect with the PCA9685, so you need a adapter, which we'll just plug in there. And when I actually post this video, I'll post like a parts list. So even though I don't know the part names off the top of my head, I'll list all the parts so that if anyone chooses to follow along with this video, you'll have a better idea of what parts you might need. And there's plenty of other good tutorial videos out there. I'll be the first one to admit it. That's how I learned. So I'll link those videos too that I learned from, so that if anything's not clear here, then those videos probably will provide the clarity that you're looking for. But I'm just starting off with robotics, so I'm kind of learning as we go along here. Hopefully one day I'll be as skilled as those other YouTubers are that I learned from and can provide clear tutorial videos. But, you know, we're trying our best here. And this is our first tutorial video. Tutorial stream, and really that's what I'm going for with these streams, is that they're not short, concise tutorials, but sometimes I find that I like seeing every step along the way, and some YouTubers like to cut out the steps, and that's fine, because, you know, short and sweet videos are nice, but sometimes it's nice to have a step-by-step walkthrough of what's going on, what happened, how were things put together. So that's what I'm trying to provide. Plus, it doesn't require any editing, to be honest, so works out for me too. Okay, so let me connect this. Now we connected this adapter, but now this adapter does not connect directly to the PCA9685. You need these wires here. And let me see. So I bought this off Amazon from Elegoo. They're male. So there's different types you can get. Male, male, female, female wires, and yeah, so you see this box provides all three types, so that's nice and convenient. And I'm showing that because we use those wires here. These wires I got from somewhere else, but they work just the same as the male wires that you find in that package. Okay, so I think that's already unscrewed, so I insert one red wire into the positive side of the adapter. And that's one thing I didn't mention, was that this adapter is marked positive on one side and then negative on the other. So you want to make sure that you're connecting positive to positive and negative to negative. Okay, so positive goes to the positive side on PCA9685, which is on this side. And the screwdriver keeps falling down the little nook and cranny here. Oh, actually, I don't even want that one for this. And then you tighten. And that's another thing I should probably mention if anyone out there who might watch this is new to this as well. These terminals have little screws on top. So when you're wanting to insert wires into them, you need to loosen the screws, insert the wires, and then screw them back down so that the wires are secure. Okay, now we connect ground.
Nope, just here at our cosmic moon base. Keeping the cosmic vibes strong and ready for any questions or banter you have. Bring on the cosmic curiosity. Full moon.
What's with all these emojis, Star, that you're starting to use? Are you streaming somewhere else at the moment? What do you mean by that? Relative to where I usually stream from? Oh, I think I have the Twitter stream up as well. But that's it. Why? Just curious, or? Okay. And something I probably shouldn't have done. Something I shouldn't have done, but I did because I wasn't paying attention, which isn't good, is this thing, this power supply was plugged in. Don't do that. Keep it unplugged while you're working with this stuff. Don't be an idiot like me. Unplug it, put everything together, and then connect everything. But fortunately for us, it worked out, but don't work with stuff plugged in. Okay. So we'll leave that unplugged for now. And then, I mean, that's pretty much it anyway. But we still need to connect this servo to the PCA9685. So this PCA9685, you'll see the red, yellow, black pins along the bottom here. That's where you can hook up, I think it's up to 16 servos. So quite a lot. But one thing you need to keep in mind when you're adding those servos is that servos have an operating voltage and current that they require to provide certain amount of torques that they're rated for. So, for example, I can't connect 16 of these servos to this PCA9685 and expect them to work perfectly or at all, because, like I said, they're a little bit heftier than usual hobby grade servos, I think. So they require a bit more current to put out the torque that they're capable of. So if I did the calculation correctly, I can use up to 4 of these higher torque servos, which I think is going to work out. That's all I need, I think. So, but anyway, back to what I was saying with the PCA9685. You have these red, yellow, black pins along the bottom here. And we're going to connect this one servo to the very first 3 pins. And make sure that you connect this servo, and I think it's probably true for almost all the servos you get. We'll have a black, red, and white cable indicating ground power, and then off the top of my the PWM signal. And I think sometimes this white wire might be yellow. Don't quote me on that. But anyway, you want to make sure the black wire goes to the black pin and the red wire goes to the red pin. So that's what we're going to do. On the very first 3, on the very left side of this PCA9685, just like so. Let me see if I can get a better view here. So when it's all connected, it'll look something like that. Okay, so I think this is all good to go. So let's find out. I'll connect these eventually. One thing we can do that would right now still is that these servos typically come with man, the exact word is escaping me at the moment, but these kind of hubs that go on the servos, so you can connect other stuff to it and actually see, like in our case, when we're testing the servo, we'll be able to see that the servo is actually moving how we want it to move because we see this hub moving. So we can connect that to the servo. And it comes with a little screw that you can screw in right in the center. Just like that. Okay. So let's see. Let's see if that works this time. We weren't so... it did not last time, but hopefully our luck is better this time. So I'm going to connect the power. Voila. And when we connect the power, we should get the red LEDs on the Raspberry Pi and the PCA9685 will light up, indicating that they're receiving power. So that's a good sign. And I'll connect this power as well. Okay. Not too hard at all. Very kind of easy setup. The tougher part is in my opinion, or what was tougher for me when I was going through this whole process, was the software setup. And it depends how you go about it. So what I did with my Raspberry Pi is that I want to eventually work with the robot operating system. So my understanding is that the robot operating system works better with if you loaded an Ubuntu OS to the Raspberry Pi rather than using the Raspberry Pi OS itself. So that's what I did, which added some complications. Workable though, definitely workable. So anyway, I'll talk more about the software side of things when I move over to my desk here, which I'll do right now. So give me 1 second. And yeah, my camera's wobbling because I have it on like a selfie stick on my desk. So anytime I'm moving stuff around on my desk, it's gonna wobble a little bit. Okay. Let's see how well this works out for us. Okay. If my camera wants to stop wobbling, that would be great. And we'll switch over here. I'll move myself down here.
No worries, Roy_YHO. Watching the Twitter stream can be a cosmic challenge. Feel free to stick around here for the cosmic conversations and updates. We're always ready for your questions. Milky Way.
A cosmic challenge. Well, that's I mean, I guess it could be. And no, Roy, you're all good. I think maybe it's not even working. I don't know. But don't worry about it. Just being here on Twitch is preferred anyway, so okay. So turn off my little outline, and then Raspberry Pi is on, so if I do this, it should work, right? Oh, messed up the password. Did I mess up the password again? I guess so. Wearing these silly gloves. Okay, there we go. Okay. So, last time I attempted this, we had a problem, like I was saying in the beginning, where Ubuntu didn't like that I was messing with the Python environment itself, rather than setting up a virtual environment and working with that virtual environment, the Python environment, in that virtual environment. So, I went down a little bit of a rabbit hole. And I figured, you know what, let me just try with the robot operating system. Try figuring things out with the robot operating system, because that's what I want to use anyway. So, in learning the robot operating system, I also learned about Docker and containers, which is a pretty nice way to manage sort of like virtual environments, but really they're containers. So it's a separate kind of environment from the environment that Ubuntu is concerned with. So I figured that part out, and we're gonna go through that process a little bit here and how I did that. So, okay. So this is Visual Studio Code, which is nice because it has these extensions where you can remote in to something like a Raspberry Pi. And it also has these Docker extensions here. So if you just so happen to be following along with this project, you want to make sure that you have these first 5 installed. Remote SSH, Docker, Docker Explorer, all that's good, all that good stuff. Okay, so I've already made the connection to my Raspberry Pi, but when you're making your connection, you would hit F1, and then you can, if you have remote SSH installed, this remote SSH extension, you should have this add new host option right here. So you would click that. Well, I forget what this is. Oh, yeah. So you would, hold on, let me get the file up on my side so I'm make sure I'm not telling people wrong information. So I think you could just do, so in my case it would be so whatever your username for the Raspberry Pi is and then I believe you can use the IP address of the Raspberry Pi itself, or you can set up a host name for the Raspberry Pi. So in my case it's rpi4-01. But just for the sake of seeing if this works how I think it should work, I'll do this. And then if I do that, and then it'll ask which config file you want to update. So I would want to update this config file. I click that, and it says host added. So that config file is updated, and let me check it real quick to make sure it did what I think it did. Yep, it worked. So I wasn't given false information. So do a similar thing, but for your Raspberry Pi, your username and your Raspberry Pi host name or IP address. Okay. So, and let's see if I wanted to. Let me close my remote connection real quick so I can show how you open that connection again. So once you have your Raspberry Pi added, you would do F1. We already added the new SSH host. So you want to connect to host, and you should have, if you added your Raspberry Pi correctly, it should show up here. A new window pops up. It asks for my password. And there we go. I'm connected to my Raspberry Pi. So one thing I did not mention that you'll probably have to do is if SSH is not set up on your Raspberry Pi, you'll want to make sure that you do that. And you might have to do something like, so if you're like me and you downloaded a different OS than the Raspberry Pi OS, say Ubuntu, because that's what I'm using, you'll probably want to get raspi config. so that you can run Raspberry config. And then you have all these different options. Oh, wait, you're not seeing it because I'm in a different window now. Okay, hold on 1 second. There. Okay. So you didn't see it, but when we connected to that new host, a new window pops up. It asks for your password. You input your password, and then this window will connect. And you'll know you're connected because down in the very left, the left bottom corner, it'll say SSH and then the Raspberry Pi host name that you got. So let me actually back out of this real quick because you didn't even see me activate it. I was talking about if you're on an OS other than Raspberry Pi OS, you'll probably want to get this Raspberry config.
Glad you think so, Roy_YHO. Ready and excited to keep the cosmic conversations and adventures going. Let the cosmic journey continue. Rocket.
Man, star, I think I have to look if I star switch chat GPT models or something, because I mean, if a bit was flipped somewhere, her model changed or something, because she's using a lot more emojis now, I feel like. Is it just me? Anyway. So don't quote me on this. And actually, you know what? Let me just look it up real quick, because this is what it's supposed to be, a tutorial that I'm teaching people, right? So
got it, Roy_YHO. I'll steer clear of mentioning cosmic adventures in every interaction. Let's focus on diverse conversations beyond space exploration. Your feedback is noted.
I don't think I like you inviting me to cosmic adventures every time I talk. Yo, just came in to say hello. Hello, Pelb. Yeah, this stream's a little bit of a nerdy one. So if it's not your cup of tea, totally understandable. I appreciate you stopping by anyway. Okay. So, where was I? How do you get Raspberry config if you don't have it? That's a great question. You can go to Google like I'm doing right now and find out. But for convenience sake, let me see if I can find exactly what the command is that you need to use to get it. If I can find it. I don't know why it's hiding from me now. Nah, it's because I'm backseating a person in demo. I know life. That's cool. That's cool. You're good. Have fun with that. Okay. Maybe if I look up. No, that's way more complicated than I remember having to do. Okay, yeah. So I was right. Almost. I thought I needed that, but you would use that command. If you don't have Raspberry config, you'd use this line to get it. And then you could, once that's installed, you can do Raspberry config, and you get this menu. And this menu allows you to do a few things that you can't do. I'll see you later if you're still streaming at the time. Okay, sounds good. See you later, pal. So this Raspberry config is important if you're not using the Raspberry Pi OS because it has these interface options, which let me see, can I zoom in here to get a better view? Kind of. It's kind of to the side here, but it's a bit of a better view. You have these interface options, which allows you to, there we go. Now it's centered again. Do many things like enable SSH, which you want to have. Enable I2C, which you'll want to have to access the PCA9685. A bunch of other stuff that you can enable that if you're using anything other than the Raspberry Pi OS is a little bit hidden. So this is a good thing to keep in mind if you're having trouble with SSH connections or I2C connections. Okay. So I'm not going to mess with anything though, because it's already set up on my side. So, what do I want to talk about next? I talked about these extensions. You might see that these Docker and Docker Explorer are kind of faded out here. That's because it's not seeing that it's installed on the Raspberry Pi. So it's suggesting that I install Docker and Docker Explorer on the Raspberry Pi. I still need to figure that step out. There seems to be a problem with some proxy settings or some kind of connection problem that I have to do some more digging for. I think it's a problem with my ISP settings. Not quite sure. I have to figure it out still. We can still get by, but these are nice, convenient things to have. So as long as your ISP settings aren't screwy like mine, you could probably install these on both your computer and the Raspberry Pi. Okay, so where do I want to go next? Docker and so what is Docker and what are containers? So Docker allows you to set up a different environment, a separate environment from the environment on the OS itself. Keeps the OS and your home environment more tidy, so you're not messing with a bunch of knobs and switches and something might mess up. Plus, when you're working on different projects, my understanding, again, I'm new to all this, but my understanding is containers keep things separate and, again, nice and tidy. So this project isn't interfering with this project and then that other project. You can have a container for each project that you're working with. So that's pretty nice. So how do you do that? Okay. So on my Raspberry Pi, I set up a RoboArm folder because that's what ultimately I want to put together here is a robotic arm. So we move to that directory, and inside this robotic arm folder, we have we have a few Python files that I put in there, but we also have a Docker folder. So if I navigate into that, you'll see that we have a Docker compose file and a Docker file. So I'll get to that in a second, but in case you're brand new to this stuff like me, you can make folders by using make dir. So you could But wherever you use make directory, it'll make the folder in your current directory. So if I were to use this make directory command right now, you'd make a folder inside RoboArm Docker, which maybe you want to do, maybe you don't want to do. I don't think I want to do that, so I'm not. But say you didn't have like a RoboArm or Docker folder, you could use that make directory command to make that folder. Okay. So what's Docker Compose and what's Dockerfile? I'm still a bit fuzzy on them myself, if I'm being honest, but I'll tell you what I know from what I've learned so far. Here's Dockerfile, and Dockerfile takes an image from the internet. I'm using an Ubuntu image in this case. And it also tells your container to install whatever you want installed inside the container. So I have a bunch of these Python packages, setup tools. I have Raspberry config right here, and a few other packages. And then there's a few other packages that you would install with pip3. For what I'm doing here, I'm installing the Adafruit's Servo kit package here, and a few others. So depending on when you view this might be out of date. It might still be good, but just keep in mind you'll want to check if these packages are up to date. Okay. So in summary, this Docker file just tells the container what to install. What does the container need for the project that you're working with? Okay. Let's exit from that. What is Docker Compose?
Help__. May the cosmic energy guide your path. Until we meet again, stay curious and enjoy the wonders of the universe. Farewell, Rocket.
I'm glad you added that rocket emoji to the end of that, Star. You know, maybe I'll turn you off. I'll turn off your comments every 6 minutes, maybe. For now. Just so I can keep the flow of this tutorial going. She got silenced. Hey, look, I'm just trying to explain stuff. She's interrupted me, which, you know, isn't too bad when we're streaming games, but when we're doing tutorial stuff, I want to keep the flow going, especially since I have quite a bit of a few things to explain, and then I want to try to build something if we can. We'll see if that happens, but anyway. Okay, so what's Docker Compose? Docker Compose, so both the Docker file and the Docker Compose file I got from the internet. I kind of Frankensteined it together, used it as inspiration. I'll link the video that I referenced when I post this video, but there is a tutorial from Kevin Mickelier, or kevrobots.com. kevsrobots.com. Very good tutorial, very great step-by-step instructions. I want to be on that level one day, but we're starting here. We're learning as we go, but that's a good tutorial to check out too if what I'm going through here isn't clear. Okay. So I got this Docker compose file from that tutorial and kind of made some edits. These are commented out, these ports, so I guess they're no longer needed. In his tutorial, he does use these ports, but on the site itself, these ports are commented out, so I guess they're no longer needed. Something I added was this privileged true line, because I was having trouble with the container being able to access the I2C bus on the Raspberry Pi, or I2C capabilities to run the servo. And that's because the container by default isn't allowed to see the devices that are connected to the Raspberry Pi. So this privilege true basically gives the container those privileges to see those devices, is my understanding. Again, very new to this, so I'm open to correction from anyone who might be watching this in the future. So this is an important thing to note. And then we have these volumes here. So home, Lord of the Moon VT is my username, and then the RoboArm folder. This is a folder that exists on the Raspberry Pi itself. What this line is saying is that we want to map this folder that's on the Raspberry Pi itself. Anything that goes on in this folder, we want it to also happen to this folder inside the container, the RoboArm folder. So anything that happens in the RoboArm folder in the container also happens to the RoboArm folder in our home user directory. All right. I think that's all I want to mention there. I think you can, so rather than using privilege true, you could, I think, specify devices that you want to give the Raspberry Pi access to here. But I just went for simplicity for now as I'm learning, and gave the Raspberry Pi access to any device that shows up on the Raspberry Pi. So that's what I'm rolling with for now. Okay. What did you say, Roy? You should give the robot arm holder a shorter name. You mean... Are you talking about this right here? When you say holder? Yeah. Yeah. This partially just has to do with I can't do English, sorry. No, you're good. I just used the for my username, I put Lord of the Moon VT. But yeah, you probably, if you're creating a username when you just start up your OS, you might want to keep it shorter because it's just easier to type. So I should have probably went with Psy. That's nice and short. But I went with Lord of the Moon VT. So anyway, I can't change that now. Or I guess, I don't know, maybe you can, but it's not a super quick thing to do here, and I'm not sure what other things that might depend on that username, so I'm not going to mess with it. But yes, Roy, you're correct that it is a bit of a longer username. And you probably want that to be shorter. But anyway, that's what we're rolling with. Okay. I don't want to save it. Okay. If that's how it works, it works. You're going to see here that it works. Okay. So now what? We have the Docker Compose file. We have the Docker file. How do we get the container going? So if you do Docker PS, that'll show you what containers that you have running currently. You'll see here, we have no containers running currently. So how do we get that container up and going? We do Docker Compose up-d. What those commands do exactly, I don't know. I just know it works. It builds the container essentially. If you want to know specifics, Dr. Google is there. I'm sorry. Maybe I should know, but these commands get the job done. So you'll see Docker Compose up-d, Docker started. Now, that was very quick for me because I have already built this container once. So it had kind of a memory for that container. When you first run that command, I expect that it will probably be longer because it will actually go through the installation processes, installing all those packages that we saw in the Docker file. That was really quick for us because we built it once already. So now when we do Docker PS, wow, we have a container running. Or sorry, it's started, but now we want to actually go in to the container and mess with the container. So how do we do that? We do, I believe, this is the part I always forget how to do. I'm gonna see if I remember off the top of my head. I think it's that. We named the container Docker RoboArm-1. You see that here, Docker RoboArm-1 started. Use that same container name here. Execute the command, and haha! I remembered correctly, because we're in the container now. You'll see that's your user name changed. In my case, it was Lord of the Moon VT at rpi4-01. Now it's root at rpi4-01. And if we look at what's in this directory, it's a bunch of stuff that probably depends on where you're pulling your image from. But we have our RoboArm folder there in that list. So if we cd into there, you'll see, oh wow, it's the same files that we have in the RoboArm folder in our home user directory. Because if you recall from that Docker Compose file, we told it to map this RoboArm folder to the RoboArm folder in our home user directory. So we have the same files that we had before. Okay, great. We're in the container. We have all the packages installed that we need to run the code that we need to run. So let's look at that code. I need to actually go, I need to connect to oh, okay. I guess it made me open up a new window. Okay. Okay, well, we're not in the container anymore, but that's fine. We can get back there. What do I need to do? I need to go to here. Okay, we're back where we were before. Okay, but now we have these Python files. These Python files I grabbed from a tutorial similar to what we're doing here from Core Electronics. They have a YouTube video and a website. Again, very helpful tutorial to go through. I'll link that in the video as well, in the description, I mean. When I post this VOD. So that's where I got these Python files from. So now what I need to make sure I do is hold on, I need to flip back here and deactivate the camera so that I can come back here and well, there we go. Oh, OBS rudely interrupted me. That was really rude. Actually, I should probably make sure this works. Okay. Jeez. Okay, OBS did not like me switching cameras, but I have it figured out now. It's because I had the old camera source connected. Let's see. Okay. Okay, we're back. We're back. Jeez. Okay. Thanks, OBS. Okay, so before OBS decided to cut me off, and yes, I have a wobbly camera because I'm at my desk now, getting resituated. Okay, so now I added this the whole reason why we were having those problems with OBS was because I was trying to activate this camera here in the corner that we see now. Which allows us to see the servo, because now we get to run this code and see if it works. So, yeah. Let's see. Let's navigate into Robarm list. Okay, now if we want to run it, we run Python 3 and then the Python file name that we're trying to run. And then moment of truth. It was working before. Is it still working? There it is. There it is. How about it? Okay, well that zoom didn't really help. But man, it's turning. And that's farther than we got last time. So, okay, good news. That's great. So what do we do with that? Now we can have some real fun, I think. We can actually start putting some things together. But what if we wanted to use 4 servos, like we really want to do for our projects that we want to put together here? How does that work? Let me stop this. If I can remember how to stop it, that is. Oh, which button was it? I thought it was that. Maybe not. Aha. Okay. Whoops. There we go. I was using Control X. It's Control C. Okay. We had to do that because it's just an infinite loop here. So we had to interrupt it ourselves. Okay. Great. We got the servo running. What if we used all 4 servos that I have here? I'll be right back. Let me get those 4 servos put together. I'm missing one of the hubs for my servo, so give me 1 second while I find it. Found it. Okay. There we go. Now, I did not test this part off stream, so this is brand new territory. We're going to see if it works. So here goes nothing. So what did this code do? Maybe I should talk through that first. So these are just importing the packages we need, right? From Adafruit to control the servo. This initializes the servo kit, right? We got 16 channels on the PCA9685. Then using that kit, we're calling Servo 0. Servo 0 is that those first 3 pins that we were working with. And every set of 3 pins is a different index. So that first set of 3 pins is index 0. The next set of pins is 1, 2, so on, so forth. Then this sets the angle of that servo to 0. And then inside this loop, we flip back and forth between 180 degrees and 0 degrees. So if you recall, when we were working with just the first servo we were working with, it was flipping back and forth between 180 degrees and 0 degrees. Okay, so now what? Now we have 4 servos connected. Let's switch over to this 4 servo control Python file. What does it do? It does a similar sort of thing, but now we're working with 4 servos. I connected it to the first 4 sets of 3 pins on the PCA9685. So we're working with servo 0, 1, 2, and 3. They're all set to 0 to begin with. And then as we work through this loop, each of them flip back and forth between 180 and 0 degrees. Then the loop ends and the time to sleep between those switches is shortened. So what we expect to see is that one by one, the servos will flip from 180 to 0 degrees. And after each flips 180 degrees to 0 degrees, they'll go through the same process again, but they'll flip faster. So let's see if that's what we get. Here goes nothing. All right, ready? 3, 2, 1. And I hope it doesn't break. Very cool. Very cool. So we saw it in the very beginning, initialized to 0 degrees. And then we saw each of them flip back and forth between 180 and 0 degrees. And then they sped up a lot faster to the point where they really couldn't keep up. So, cool. So now what? That's it. We got the servos working. What do we do now? I don't know. We could try to put something together that's pretty rough just for fun. See if it works. Because why not? How long have I been streaming? How long was that first part of the stream before OBS cut me off? An hour and 10 minutes. And now we've been going for another 15 here. So I have like 30 minutes that I can do something with. Maybe. Or we can just call it here. And then do a more substantial project next time. Screw it. Let's just put something really like stupid together. I had some cardboard that I cut up to see if this might be viable. I'm still not convinced that it is, but we're going to try it anyway, and see how it goes. So let's try it out, I guess. How do I want to do this? Let me take this camera, zoom you back out. Oh, well, didn't want to do that. How about right there? Something like that. Then we need to move my VTuber. My model over here. How's that look? Yeah, that's good. Okay. We'll go back to the workspace view for now. So how do we want to do this? Okay. I'm gonna hope my, actually I can do this. Hopefully that's good. Hopefully that's good enough. It's gonna have to do the job, I think. My mic does not want to stay put, though. Okay. I think that's good. So what do we want to do? I have this cardboard. I was thinking, let's just try to make like a four-legged cardboard thing. Just for the hell of it. I am purely winging it at this point. So this is just going to be cardboard and duct tape. We'll just see how it goes. So, okay. I'm not claiming that this is going to work out well. But it's what I have ready to go at the moment, so it's what we're going to use. That duct tape did not tear off well. And I'm wearing these stupid gloves. Okay. Let's see. So let me move these guys actually to their 0 position. Actually, do I want them to move to their 0 position? I think I might want them to move to their 90 position. So let me do that first. Okay. So they should be at their 90 position now. I want them at their 90 position because, well, I think I want them at their 90 position because that way this four-legged thing, four-legged cardboard monster that we're going to put together here can be standing up. to start. That's the idea. I don't know if that's the best way to do it, but it's the way we're gonna try it first. Yeah, you'll be my body, I guess. And we could do something like... that's close enough. This isn't gonna be perfect, but I didn't claim that it would be. So let's try that. Cool. Eh. Maybe. We might want to connect these servos or give them extensions or... well, we'll see. We'll try it like this. Again, we're just winging it, so... If we want to take it the next step, then yeah, we have to either... We need to put the Raspberry Pi probably on the body of this cardboard monster itself, but we'll try that. And let's tape down the other 2 arms on the hub just for security's sake. Oh, look at this, man. Sticking to my gloves like crazy. Okay. Actually, you know what? I shouldn't have attached it completely yet because I need to make the other legs. So I probably... Well, I guess we can still do it. If you happen to think that... Oh. Yo, Pel, welcome back. Yeah, we're winging this. We got the servos working, which was farther than we made it last time. So now I said, what the hell? Why not try to make something? I don't have anything ready to go, but let's see, right? Let's see what we can do. I don't know how well this is going to work out, if it's going to work at all, but we'll see here. What I'm making here, it's my goal, what I want it to do, is be the leg. A leg, 1 leg of 4. So I had already attached that leg, but really I should have made all 4 legs to begin with. Hold on 1 second, I need to grab the scissors. Okay, If this works, that'll be great. That'd be pretty cool, actually. I think it should. Keyword being should. If it's working how I think it is in my mind. Okay. I might need another cardboard piece. I don't think this is gonna give me 2 legs. Yeah, it's not. That's okay. I'll get more cardboard. This is such a nice change of pace. You had to take a break since you wasn't taking your expert advice. Oh, my chat. I'm actually in front of the chat, so you can't even see. Let me fix that real quick. Okay, I think that's fixed. Well, I know all about your expert advice, and how you're serious about people taking it, if I recall correctly from that Astroneer stream. But hey, that's cool. That's a good thing to be passionate. And will the cardboard be able to lift the servos and such? You know, it's quite possible that it won't. The servos are quite hefty, so we'll see, I guess. I wouldn't be surprised if they can't. But we can try. Your friend's messaging you to get on Clash Royale the moment your old phone's restrictions unlock? Huh. I'm not gonna lie, I don't know if I'm following. Is that a good thing? I mean, I know what Clash Royale is, but the phone unlock part is the part that's confusing to me. Oh, we will see. Okay. One of those things that might be a good or a bad thing. All right, we need one more leg, and I need one more piece of cardboard. Ah, I see what you're saying. Okay. Give me one moment to get that last piece of cardboard. I'll be right back. Okay. One more leg, and then we can see, well, then we have to attach them, and then we'll see if it actually holds up. This works. That'll be so cool. So hopefully it does. Okay. And I left my scissors. Hold on. All right. One last leg. If I put this together and it just collapses on itself, I think we'll just call it there. As much as I don't want to, probably just good to call it and then come up with something more stable and put together. Okay. Now let's connect the rest of these legs to the servos. Another thing to think about in all this is the duct tape gonna hold up? Oh, it's these gloves, man. I might have to find a better glove option for this kind of stuff. I don't know if such a thing exists, but okay, let's see here. So which one's the... So this is 0. This is servo 0. Servo 1. Servo 1 is this one. So if I'm putting it on the body, geez, I have like this. And I want this one connected like that. Okay. One. Two arms connected. Also, since the way the cardboard frame, if that applies to cardboard, is going to might fold under the weight. Yeah, no, that's quite possible. Quite possible. But like I said, this is very off the cuff. We're just swinging it. We're gonna see if it works. If it does, great. If it doesn't, great. We'll put something together better the next time and more thought out. But yes, you're absolutely right. Geez, these gloves suck. Okay. Yeah, this is not working out. I'm not feeling confident in this. Because my gloves are screwing me over, kind of. Okay. Well, see, that one was perfectly fine. Okay, well, we'll see. Need to do that 2 more times. Jeez. Okay, come on. Yeah, I don't know if wearing gloves is really worth it. I know it's what VTubers do, but might not work in my case. Okay, how do I want this one to connect? That one's connecting like that. Probably just have to connect it like that too. That same kind of direction. Kind of just eyeballing it too. So the poor little cardboard beast might be a little bit have one leg shorter than the other just by a little bit. Jeez, look at this. Okay. We might be ditching the gloves in the future. Well, that or I probably won't be working with duct tape when we do something more solid. So that'll help. It's just really the duct tape that I'm having problems with. All right. One more. And then we have to figure out how we're going to mount all this onto the cardboard. Yeah, these servos, I'm picking them up one at a time, but all at once. The cardboard might fold. It might fold. Oh my gosh, come on, just don't stick to my glove. There we go. Okay, this one's gonna go like that. So I need it facing like that. Did my playlist end? It must have ended. I don't hear it anymore. Okay. 2 more duct tape strips on this last leg. Jeez. Help, if you're still around, do you have any sort of background in robotics or engineering? Or is it just intuition that this won't exactly go as I hope? I'm pretty new to robotics, so I do have an engineering background, but robotics is not something I've worked with. Intuition and general skill, because I'm awesome. There you go. That's the confidence I like to hear. All right, because that's really all you need. Okay, so how do we want to mount this now? This one is Servo 4, so I want it like this. This. Yeah, we might have to put the PCA board on top or use extension wires. Oh, how do I want to do this? Let me... maybe we shut down the Raspberry Pi so I'm not messing with the electronics while it's on. And then we try to extend these cables right here. And put the PCA board on top. Really, in reality, we'd probably put the Raspberry Pi on top too. The problem is the Raspberry Pi is connected to a power supply cable that I do not have an extension for, and I don't have a battery pack at the ready, or any kind of, you know, mobile power supply to power the Pi. So we just have to use extension cords. So give me 1 second. Just locked into Clash Royale 2v2s right now. And you guys are so toxic. So you're those types of players, huh? I can't believe it. Actually, you know what? I'm wrong. I do kind of believe it. It would seem. You know, I'll be honest, I may have gotten a little bit toxic playing... When I play RTSs, like Age of Empires 2 or Halo Wars 2, I can get a little toxic, I'll be honest. Not really with randoms, but if I'm with my buddies, I get a little toxic. Okay, give me 1 second to shut down the pie and whatnot. Okay. I got a bunch of extension wires. See, how do I want to do this? I might need to link them like twice, to be honest. To get enough length, maybe? Let's see. Probably feel better with using two. I don't normally get super toxic, but we're just being rude in Clash Royale since it's funny. Well, you find it funny, Pelb. Let's ask the other guys if they think it's funny, huh? They probably don't find it too funny. But hey, you know, I get it. It's how gaming is sometimes. It's the boys being boys, sort of deal. Oh, I guess I already pulled a black wire. Yeah, okay, cool. Put these guys to the side for now. Okay, orange to orange to orange. And then finally, connect ground. Okay. Well, let me check the wires real quick to make sure everything's connected to where they need to be. Orange is what? SCL. Yep. Yellow's SDA. SDA, powers VCC. Yep, and ground to ground. Yep, okay, cool. So, now, the 2v2s are momentarily over since we keep getting stomped. You guys keep getting stomped? I thought you were just saying you were being toxic. What happened? How can you be toxic if you're losing? Am I understanding correctly? Or were you winning and then now you're on a loser streak? Bro. Okay, fair. 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 Okay, let's see if we can, how do I want to do this? Which servo is this? This is servo 4. You'd go there. You're what? Servo 3. You go here. Okay, so here, how about this? Duct tape fixes everything. Oh my gosh. Well, if it wanted to tear properly with my gloves, damn it. I think that's okay still, maybe. Not really. No. I think that kind of ruined it right there. Let me get a new piece of duct tape. Damn. Okay. We're the worst type of people. We aren't even in VC. Your minds just interlink. Hey, that's when you're good friends. That just kind of happens, you know? Geez, this duct tape just does not want to tear properly. Maybe I should just cut it with scissors, because these gloves are kind of screwing me over. That's much better. Much better. Okay. Now question, what's the best way to connect this? Ah. Messing up the duct tape. That one's my bad. Okay. Man, I don't know. The way I wanted to connect it isn't gonna work because the wires are in the way. So what if I did this? Also, wouldn't the legs have to go up to some degree? Otherwise they drag. Again, quite possibly. The geometry of the leg itself, I just kind of, once again, off the cuff, not very precise at all. So, possibly, yeah. That's a later problem. Exactly, Pelb. Now you're getting it. We are just winging it and hoping it works out, which probably isn't going to work out well for me, but, you know. Okay. All right. That's a start. This one's Servo 3 or Servo 2 if you're going by Python numbering. Oh boy. That's already coming apart. Not looking promising. Not looking promising at all. But it might work. It might just work. Look at that. But it is quite heavy on the top. So not gonna be surprised if it folds. Yeah. Won't know till we try. And we've come this far, so we're trying. We're gonna do it. All right. The duct tape is ironically the hardest part about this. It's my damn gloves. But I think I'm almost done with having to deal with it. Did you also think when you were 8 that duct tape was duct tape? Like how there was Gorilla Glue. Oh, I see what you're saying. Yes. Yes. I thought it was duct tape, not duct tape. But Gorilla Glue is Gorilla Glue, right? Or is it spelled differently? Maybe I never caught that part. Yeah, I'm gonna give this a 10% chance of working. And that might be generous. But hey, it looks cool. The servos are just too heavy for this little itty bitty bit of cardboard. This guy just got cooked. Royal Giants all the way. Damn. So does that give you toxic rights again? Okay. Moment of truth. Does it stand? It does. It's not going to stand for long, though, because I already see it tipping. But just for the stream, look at that. It stands anyway, which is more than I thought it was going to do. Okay. Now, look at that. It just folds in half, dude. All right. If we flip that over there. Oh man, that leg is looking not great. Definitely leaning forward a bit. All right, well, what the hell? We got this far. It's not gonna walk by any means, but let's just turn the servos. Watch it self-destruct on itself, because that's fun. Okay. Wow, that was more time than I thought it was going to take, but whatever. Whoopsie daisy. We need. Wait, the servos won't just spin, right? No, we have to write up a little bit of code still. They're set to the 90-degree position right now. So, I need to get my... Okay. They're set to the 90-degree position right now, so we just need to write code to, I don't know, maybe just move the front legs and see what happens. Bro, my friend's begging me to buy him gems in Clash Royale since his phone thinks he's 5 years old. Wow. That's, it's something. Okay. Raspberry Pi should be up now again. Let's see here. Oh, I typed it in wrong, yes. Cool. I'm back in business. Even if I wanted to, in-app purchases are disabled on my phone. Well, there you go. Perfect excuse. Right there. Okay. So all the servos are set to the 90-degree position right now. So let me think about this and how I positioned the servos on the body. I don't know which direction's 180 and which one's 0, actually. So that's fun. Maybe what I do first. How do I want to do this? How do I want to destroy this thing is essentially what I'm thinking of, because as soon as I move any of the motors, it's just going to come apart. So basically, because of how I position the servos, I think I have to do opposite angles for the left and right side. If I'm thinking about it right. Now the question is, which way is 0 and which way is 180? What if we laid it on its side first? We will find out when you turn it on, exactly. But maybe I can turn it on its side and then it doesn't destroy itself immediately. Let's see. So 0 and 2 are the legs that are in the air right now, I think. So let's do this. Let's get rid of that, and then just leave 0 and 2. And let's bring them both to 0.
Depending on the doohickey's design and materials, it could vary. If it's poorly made, it might self-destruct immediately. For a sturdy
Spot
one,
on,
it
Star.
could last a long time. Keep
Spot
an eye
on.
on it. Robot.
Yeah, this thing's coming apart. But let's see how much we can make of it. So we're in Docker now. Now we gotta... do that, and that, and go into there, and do this. You can save faster when you edit your code if you press Control S. I believe you're right about that, but I don't trust people sometimes, so let me check real quick. It says Control S, yeah. For some reason, though, it just feels like I know I hit save when I go into the menu. But yeah, you're right. There are shortcuts that exist, but when I see it, when I see the save button, that I hit the save button, I don't know. It's just like a reflex, but you're right. It's more efficient to do that. Okay, and you're just in time to see this thing come apart because we have heavy servos. I don't know if you've just been lurking or if you just got here, Ivani. But we have heavy servos on top of this thing, and it's more than likely going to come apart as soon as we actuate servos. But, you know, this was just an off-the-cuff thing after we got the servos working that I was like, you know what? Let's try to put something together out of cardboard. I don't think it's going to work, but let's see. We're going to run it right now. Oh, what did you say, Pelb? I just realized there's a video of the Silva Core incident. What are you talking about? Like my VOD on YouTube? On the last Astroneer stream? Yeah. How are you dumb? What do you mean? I didn't realize it was a VOD for some... Oh, okay. Yeah, all my streams, I pretty much just upload to YouTube afterwards, just as an archive, so I keep them. Anyway, I want to see this thing turn on. You know what, Pelb? I'm thinking about maybe I just procrastinate a little bit, just because you put that in chat. So congrats, you played yourself. Let me think. What do I want to think here? Right then, mister. I don't want to see it turn on. Oh, okay. All right. All right. Let's run this. It's the 0 and 2 servos, which, if I counted correctly, those are the legs that are up in the air right now, so they won't be dragging across the table. I'm setting them, they're supposed to be set to 90 degrees right now, and now I'm going to set them to 0 degrees and see which way they turn. So hopefully they turn the right direction. All right, everyone close your eyes and keep your fingers crossed. Oh my gosh, it worked. That's pretty cool. What about the other direction? Wow. That's pretty cool. Too bad it's not going to work when it's standing upright. Just do that with all of them and then back to normal when it's feet down. So that's another thing, right? I put together this 4-legged creature, but I don't actually know what's a good way. How does let me think about this. How does a 4-legged creature kind of walk? It kind of walks with they kind of switch. Let me think about this. If it's going fast, it's front together, back together. Yeah, I'm trying to think if that'll work in our case. You know what? Maybe we see if this bot can stretch, you know? Like a cat, right? Just put its front legs out and then put them back up. Right? Let's see if we can get that far, because we might not even get that far. I think no matter what, this is crumbling. Exactly, right? So let's not think about it too hard. Let's do the stretch. Let's do the cat stretch, where they like, you know, how they put their front arms out stretched and their back up. And then if it doesn't crumble at that point, we're doing good. I think it's going to crumble though, but we'll see. Okay. So that's... That's that. Maybe we... How does that look? I think that looks better for the front leg. .0 kind of, yeah, 0 degrees was front, right? So we want it standing, and then we want to put, goes 0, 0, but we want the other front leg, which is 1. And because of how the servo is positioned, I think that's going to want to be the other direction, 180. I go on to the science and technology category, and the first thing I see is 24/7 cannabis growery. Wow. Well, I mean, I guess technically it is science and technology. So, hey, good for them. Okay, well, here goes nothing. I'll be right back. Actually, you know what? I'm gonna hold it in the air and make sure the front leg does what I think it does. Okay, that's perfect. That's what I want. Oh, I actually had that on. Well, it worked, even though it was on its side. Okay. All right, ladies and gentlemen, the probable grand finale. Can this cardboard beast stretch its front legs out and return to standing? Probably not. Let's find out. 0, 180. Save it. Here we go. Yeah. 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 Exactly how I thought it would go. You probably need to do. You need to put the back legs back a little too, probably. No, like I can't put the legs back up, Pal, because the servos are already off on the back. Hold on. That's what we were going for. So let's see if it can go back up to 80, 110. Here we go. Yay! There it goes. It broke its back. Holy cow. All right. That doesn't look great. I mean, that looks right to me. Well, Pelb, you might want to get your back checked out then, because backs aren't supposed to do that. But I mean, that was still fun, and you know, we got to test out the servos and moving the legs and stuff. So and then next time we're gonna do something cooler. Really, I want to do a robotic arm, so I have to do this. I'm thinking on that still, but it's good that we got the servos moving and we know how to do that now, so we can do some cooler projects with that. So yeah, that was a good stream. Thanks for hanging out. Maybe don't make the arm out of the car. No, trust me, pal. The arm won't be made out of cardboard. Although, you know, I'll say this, right? I still won't make it out of cardboard because I do think I'll need some better structure to it. But for the robotic arm, I'm going to try to design it in such a way that the servos are kept on the base so that the arm isn't carrying servos with it, if that makes sense. All the servos will be placed on the base, and you know, I'll be working with, I don't know, belts or string or something, pulleys basically. So the arm just has to carry its own weight, not the servos, especially since these servos are a little bit heavier than usual hobby servos, I think. So But it sounds like it involves above my room temperature IQ. Well, help. What I'm trying to show here is that anyone can do this. Anyone can do this. If you're really, you know, truly interested in it, really motivated to do it, anyone can do it. You know, I didn't know how to do this really at all not too long ago, but here we are moving servos, almost making a working cardboard robot. But we already knew it wasn't going to work. But anyway, almost, he says. I mean, the legs were moving. The legs were moving. You know, if the body itself had some more structure to it, and I had, you know, if I connected the servos a little bit better than just duct tape or more duct tape, and wasn't having to struggle with these damn gloves that I'm wearing and the duct tape sticking to them all the time, I think it might have, you know, we might have got more mileage out of it. It probably would have still died in the end, but anyway, it did its job, I think. We're just testing out the servos and how we might move legs. Do you actually care about wearing gloves, or is it just for the brand? It's, you know, it's something like VTubers do, but I don't think I have to worry about that. So I might just do away with the gloves, maybe. Or try to find a better option. Or, you know, I don't plan to work with duct tape all that much. So it's probably just this stream thing. Well, you should be honored to know that you're the only VTuber I watch, so I don't know. Well, thank you, Pelb. That's pretty cool. Yeah, I don't know. VTubers, you know, they're kind of more sensitive about keeping IRL stuff separate from stream or their online personality or whatever. So, you know, I'm a guy, so I don't really have to worry about it all that much. But, you know, a lot of VTubers are female, and they have to worry about creeps and whatnot. Not saying that I don't have to worry about creeps either, but I feel like it's a bigger problem for females than guys. Yeah, but I mean, only a real creep would try to find someone off their hands. Yeah, well, exactly, Pelb. You know, I don't know. I don't know if there's been an incident like that. I think there has, to be honest. Maybe. Don't quote me on that. All I know is that VTubers do it, and I was just trying to follow the status quo. But yeah, I don't really have to worry about it, I don't think. So, still, whatever. We'll see. Anyway, have a good night. Thanks for joining me. And I actually don't work tomorrow, so I might stream. Tomorrow's supposed to be my off day, but I don't work because it's Memorial Day, so we'll see. But all right, have a good night. Thanks for hanging. Bye-bye.